let's now look at how atoms are able to form ions. What are the mechanism that goes behind the scene for them to actually form ions, right? We actually start with basic definition of what ions are, and then we now move to understand what's going on within the atom to have this particular thing. So what are ions? Some people call it ions, right? Ions formation or ions. Let's look at that now. What are ions? Guys, ions are chemical species formed from atoms or other ions as a result of loss or gain of at least an electron, right? So the loss or gain of electrons from the atoms, entire atom, is a result into formation of an ion. That's how ions are formed. So when you have an atom, the atom can be neutral or non-neutral. We'll talk about that in a minute. But then just know that ions are chemical species, right? Formed from atoms or even other ions as a result of loss or gain of at least an electron. When an electron is lost or when an electron is added to a particular atom, then we are probably going to have an ion form. Basically that. Wow. So we have to know that they are chemical species, right? And then these chemical species are actually charged. Charged. So meaning they end up having a charge. They are charged species. I should have said that in the definition. Ions are chemical species. Yeah, let's say are charged chemical species here to make the definition very solid. Yeah. So ions are charged, right? Ions are charged atoms. Yes, let's call them. You can call them charged atoms. So atoms that are charged. But what do we mean by that? In the previous session, we talked about atom having the same number of electrons as proton. So the number of electrons that we are having around the shell is the same as the proton inside. We say all the protons are positively charged and all the electrons are negatively charged. If the number of protons and the number of electrons are the same, then maybe if you have three protons, so we are going to have plus three, and we have three electrons, you are going to have a charge of negative three. If you put all of them together, plus three and negative three, you are going to get zero. So the atom will be electrically neutral. It will be electrically neutral, right? So that's what. So those species that are having the same number of proton and electron, we basically just call them atoms, right? But whenever there's an imbalance, whether there's more proton than electron or more electron than a proton, we now call them ions. That's what that. So because they will not be having charge. Let's assume the proton is plus three and the electron is negative two. When you add these two, plus three and negative two, you are going to have negative one. So we are no more having zero, but we are having a minus one, right? A minus one is a charge, negative one charge. Or you can have plus 3 and minus 4. Then the result will be no, oh, plus 3 and minus 2 should be positive 1. Sorry. Hey, that was simple math. So plus 3 and minus 2 is positive 1, and this one is minus 1. So this one, the positive one, just means that this is charged, right? It's not zero, so it is charged, but it is positively charged, giving us the idea that there is more proton than electron, right? How many proton are there? There is one extra proton. That's plus one. The one is telling you there's one proton, right? That there is one extra proton over electron in that particular species. But for this one, we are having negative one. Negative means here we are dealing with electron is in excess. Electron is in excess by what amount? By one amount. So meaning there's an excess of an electron over proton in this particular species. Yes, that's what they mean basically. So if I give you plus 5 and negative 3, meaning there is plus 5 charge of electron and negative 3 of electrons, then what are you going to have? You're going to have plus 2. This is telling you that this particular species is positively charged. Positively charged means that there's more proton. Protons are the one that are positive and electrons are the one that are negative. So plus 2 tells you that there is more proton than electron, right? But the the proton is in excess over the electron by 2 amount. So mean there's more extra 2 proton over electron. But if you had negative 5 and plus 3 and we put it together, we have negative 2. This is telling us that this is negatively charged, meaning that okay, the species that are negatively charged in the atom are electrons. And if it is negative 2, meaning that there's more negative species component than the positive component. Okay, and then these negative component, which are electrons, are in excess over the protons by 2, right? That's the minus 2, just telling you that amount. Yeah, this number will be putting them mostly, if you have an atom, we'll be putting them here. So you'll be seeing species written as x to the power 2 minus, yeah, we will say negative 20, but when we are representing them, the charge comes last. The charge comes second. So after the number, then second. So you have example like Na plus, this is sodium plus. So this is plus, plus. If it is 1, we don't write the 1. We should, if it is, we should have normally written it like this, 1 plus. But because it's 1, we don't write it. We just say Na plus. So there's something like Ca2 plus, right? Ca2 plus. It means that in this particular species, there is uh, the protons exceed the electrons because it's positively charged, and then the protons are in excess by 2. That's what the 2 is telling you, and the positive tells you which species is in excess or not. But if I just give you something like Ca, then this one is not a, we are not talking about ions, we are talking about the neutral atom, because there is no charge here, the charge is 0. There's no charge here, charge is 0, right? So we don't write it when it is 0, we just say Ca. Yeah, so this is, yes, calcium atom. This is calcium atom, but this is calcium ion. This is sodium ion. This is calcium atom. This is calcium ion. Okay. What do we need to know again? We need to also know that because they are positively and negatively charged, they have different names. Positively and negative charge, they have different names. Those that are positively charged, we call them cations. And those that are negatively charged, we call them anions. If they are none, it's just an atom, just a neutral atom. So Ca2 plus is a cation, Na plus is a cation because it is positively charged, and then this X2 minus, let me just write Cl minus, this is chlorine, right? Chlorine, this is an anion. So what can make you remember that it's positive or negative? Just N inside, and N for negative, anion, negative, right? So you just have it. If it is not negative, then it will be positive. Then it will be the other one, cations, right? Yeah, that's how you can work. That's how it works for me. So when a species is negatively charged and they say what's the name, anion, not the cation, anion, negative, N for negative. Yeah, that's how I used to actually get this thing quickly. Yeah, so yeah, all the charges that to be negatively charged, we call anions, but all of them together, once they are charged, because they all have a charge, we call them ions. But if it is positively charged, we call them cations. If it is negatively charged, we call them anions. As simple as that. But then in this thing that we are talking about, there's proton over excess proton and electron, right? But what is actually happening is that it's not that uh no, let me refer to the definition again. See, when we're doing the definition, we said that ions are charged chemical species formed from atoms of other ions as a result of loss or gain of at least an electron. So it is electrons that are being lost. Proton can be in excess sometimes, but the thing is, protons number is always fixed. It is the electron that are changing, right? So either an electron adds to the atom or an electron leaves the atom. Whether an electron adds to the atom or leaves the atom. So assuming we're having plus 5 and plus and minus 5 of electrons. This is a neutral atom because if you add it, it's negative 2. But if you remove one electron, right? If you remove one electron, we don't touch the proton, they don't go. I'll explain that in a bit. The proton don't go, right? But then it is the electron these are the electrons, these are the protons. But these are neutral atoms because they are all same charge. But the information of ions, protons are fixed. So how do what do we do if we add an extra electron from somewhere, we add it to this, it become negative 6. Now we have plus 5 and negative 6 now. We are going to have negative 1. Then, meaning that we have added an electron. So there will be excess electron over proton, right? Yes. So the charge become negative 1 now. Basically that. Or if you're having plus 5 and negative 5, we don't touch the protons. But then we can take one electron away from this one. So minus 1 electron. Then you have plus 5 and negative 4. This plus 5 and negative 4 will give you plus 1, right? Meaning that there is an extra proton over electron. So technically, the proton's number doesn't change, but the electron number is the one that changes. But why? Why should it be electron? We've looked at we've seen that in the previous session where we said that we compared in terms of mass, right? We said that the mass of the electron is very insignificant, so it's almost zero. But the proton and electrons, right, they are having significant masses, and they are located inside the nucleus, in the middle of the atom, right, somewhere in the middle of the atom. So, but then when we are interacting with this atom, for example, right, if you are interacting with this, it's as if you are putting your hand inside the atom. If you want to put your hand inside the atom, the first species that you meet are the electrons because they are on the shell. Then you want to bypass all these guys and reach out to the proton. Electrostatic, these are charges, right? You'll be encountering charges along the way. But then the easiest thing is to remove the electron from we actually start removing from the first shell. So when you are putting your hand inside the atom, right, you meet the first shell, you see an electron, they remove it. So it's easier to remove the electron than the proton, which is inside. Also, because the electron is having an insignificant mass, it's not having enough weight. It's not having a weight. So it's simple, it's easy to remove the electrons other than um, trying to remove the proton. So in chemical species, right, in chemical reactions, it's the electrons that dissipate, the electron that moves in and out, giving the ions a particular charge or not, right? If you remove more electron, meaning there's going to be more proton in the atom. If you add more electron, meaning there's going to be more electron than this. That's how cations and anions are formed. So those are the reasons why electrons are the one that contribute to the charging nature of the particular atom. They are the one that are moved because they have insignificant mass. So let's say they are massless, and also they are, when interacting with the atom, they are the first that you can meet, right? Especially on the shell, they are all around the shell. So you encounter them the shell first, so you can easily remove it from there. Protons are inside. Going deep there might be electrostatic force or anything may happen. The whole thing may explode. We don't know what happened, right? But the most important thing is that we remove the electron. So we regulate the number of proton and we regulate the number of electron and proton in order to contribute to the formation of ions. So yes, basically that's how ions are formed, right? Ions are formed from the loss or gain of electrons from atoms or other ions, right? And then they make the atom charged. The ions are actually charged in nature. So whoever becomes more becomes give each charge. If there's more proton, then the charge becomes positive and we call it cation. If the charge is negative, then there's more electron and we call it anions. Anion, N for negative, anion. That's how I used to remember all of that. Yeah. So in the next session, we will look at molecules and compounds. Molecules and compounds. In this particular session, we got to understand how ions are formed and how they are. We'll be using them in naming of compounds. But then when we get to compounds, we are going to have basic idea of ions and molecules. Then we begin to name some substances or maybe look at the periodic table before doing that. Let's see what we can do in the next session.